Differential Calculus, question 10b, 2018. If there were no immigration, the population X of a certain country would increase at a constant rate of 2.5% per annum. By emigration, the country loses population at a constant rate of n people per annum, where time is measured in years. Then the x dt is equal to x over 40 minus n. If initially the population is p, find in terms of npt the population after t years. Okay, let's have a look. dx dt, we want t, so we're going to have to simplify and get this dt on its own. dx dt is equal to x over 40 minus n. I'm going to make this into one single fraction, so the x dt will be equal to x minus 40n over 40. I want dt on its own, so I need to multiply across by dt, and then it's going to divide by the fraction, so it's going to turn the fraction upside down. So we're going to have dt is equal to 40 over x minus 40n dx. I could leave the 40 there and integrate it with the 40, but I could also divide by 40 and integrate. We know if we integrate dt, we're going to get back to t, so we're going to have to, it doesn't really matter which way we do it. So let me divide by 40 and we'll do it that way. So dt, 1 over 40 dt, if we integrate that between t and 0, and we integrate the right hand side, and it's between initial population, initially was p, so that's my p between x and p of 1 over x minus 40n dx. We should be able to simplify this down. So we're going to get t over 40, or 1 over 40t, between t and 0, which is just going to give me t over 40. So that's equal to 1 over x goes to the natural log of x when we integrate. So 1 over x minus 40n is going to go to the natural log of x minus 40n. So we're going to get the natural log of x minus 40n between x and p, and we put our x and our p in for x, so we're integrating in respect to x. We're going to get the natural log of x minus 40n minus the natural log of p minus 40n. And that's the difference of two logs, so we can turn that into a division of logs. So that's the natural log of x minus 40n divided by p minus 40n, and that's equal to t over 40. To get rid of the natural log, we have to raise the other side to the power, e to the power of, so that's going to be e to the power of t over 40 is equal to x minus 40n over p minus 40n. Just let's check what we were asked again. We're asked to find in terms of n, p, and t the population, which the population was x. So we need x on its own. So p minus 40n by e to the power of t over 40 is equal to x minus 40n. So just bring that 40n across, and we're going to get x is equal to p minus 40n times e to the power of t over 40 plus 40n. In part 2 of this question, we're given some numbers for the variables. N is 800, p is 30,000, and the population is 29,734. So let's just write them down and fill them in. N is equal to 800, p is equal to 30,000, and x is equal to 29,734, and we're asked to find t in years. Find the value of t when the population is 29,734. Okay, so fill our variables in. 29,734 is equal to 30,000 minus 40 by 800, and that's times e to the power of t, this is the t we need to solve for, over 40, plus 40 times 800. So that will give me 29,734 is equal to 30,000 minus 32,000, so that's going to be minus 2,000 e to the power of t over 40 plus 32,000. So if I make them both positive by bringing the e to the left, I'm going to get 2,000 e to the power of t over 40 is equal to 32,000 minus 29,734, and that's going to give me 2,266. So e to the power of t over 40 is going to give me 2,266 over 2,000. And to get rid of the e, we need to get the natural log of both sides. So that will give me just the t over 40 will be equal to the natural log of the right hand side, which is 2,266 over 2,000. So just multiplying by 40, t is going to be equal to 40 times the natural log of 2,266 over 2,000, which could be simplified earlier in the question. So 40 times that is going to give me 4.99, so 5 years.